Hello and welcome to Math 8, Unit 1A, Lesson 3. Today's objectives. Scholars will estimate square roots and place them on a number line. So we're replacing square roots on a number line. So first let's talk about how we can find square roots. Well, of course, we could use our calculator. We could also estimate using known perfect squares. So of course on our calculator, we're literally going to say, okay, the square root of 50, and we hit equal sign, and it gives it to us. Please know on some calculators, you have to type 50 and then push the square root button. You'll get to know your calculator and know which way your calculator requires it. Okay, so the other option is we can estimate using known perfect squares. So what do I mean by that? Well, perfect square, well, we'll get into that. So, square root of 50, I know must be between the square root of 49, which is, 7 squared, right? And the square root of 64, which is 8 squared. That tells me the square root of 50 must be between 7 and 8. Probably closer to 7. Okay? We'll talk a little bit more about that in just a minute. So also a thing to remember is that there are positive and negative square roots. If it doesn't ask you and just says, give me the square root of 4, please know that the square root of 4 is not just 2, it's also negative 2. Because negative 2 times negative 2 is also 4. Or I say negative 2 squared. And you notice I'm putting this in parentheses, is 4. If you put this into your calculator, it will come out correct. If you type this, negative 2 squared, your calculator sees negative times 2 squared and will give you negative 4. Please know that no perfect squares are negative. So just like the square root of 4 has 2 and negative 2, the square root of 9 is 3 and negative 3. There is a positive and a negative square root. So what are the perfect squares? So here are some perfect squares that you should know. The square root of 1 is 1 and negative 1. The square root of 4 is 2 and negative 2. And you'll notice I did give you this on your note sheet. The square root of 9 is 3 and negative 3. The square root of 16 is 4 and negative 4. 25 is 5 and negative 5. 36 is 6 and negative 6. The square root of 49 is 7, negative 7. 64 is 8 and negative 8. Keeps going. So you should basically have up through here memorized. Above that, they're probably going to give you a calculator. Okay? So I gave you some perfect squares. Above that, something like 400 is 20 and negative 20. 900 is 30, negative 30. Well, what about fractions? Fractions, we take the square root of the top and the bottom. So the square root of 1/4 is the square root of 1 over the square root of 4. Well, I know both of those. It's half and negative 1/2. Same thing with 1 and 100. I can check square root of 1, square root of 100, and so on and so forth. Again, I gave you this list on your notes. Okay, so in order to use perfect squares to estimate irrational numbers, first thing we need to do is look at our number line and figure out 1 is the square root of 1. 2 is the square root of 4. 3 is the square root of 9. 4 is the square root of 16. 5 is the square root of 25. 6 is the square root of 36. 7 is the square root of 49. 8 is the square root of 64. 9 is the square root of 81. And 10 is the square root of 100. Okay, so now we need to place these numbers. Here I have the square root of 20. Well, if I look through here, I see that if I scroll through these, the square root of 20 falls between the square root of 16 and the square root of 25. So, the square root of 20 goes right here between those. Do the same thing for the square root of 50. Square root of 50 is in between the square root of 49 and the square root of 64. So, square root of 50, and it'd be closer to this side, goes right there. But the square root of 6, well, it's in between the square root of 4 and the square root of 9. So I'm just going to put that there, square root of 6. Now the square root of 75. Well, it's going to fall in between the square root of 64 and 81. So, square root of 75. And I've got one more left. And we'll go back to red, I guess. Square root of 90. Well, square root of 90 is between 81 and 100. So, square root of 90 goes in between 9 and 10. So we just put those all in the number line. They're not perfectly exactly where they belong, but they're in between the correct sets of numbers. Sorry. So, estimate them without a calculator. So, let's talk about actually estimating. Not just putting them on there, but estimating them without a calculator. So, the square root of 70, we looked at that. What are the perfect square roots above and below it? We said it's between the square root of 64 and the square root of 81. Remember, the square root of 64 is 8. Square root of 81 is 9. So its value must be between 8 and 9. But where? So let's figure out, what is the total distance between 64 and 81? Well, 64 plus 17 will give me 81, so 17 is our total distance. What is the distance from 64, that bottom one, to 70, the number we're trying to find the square root of? Well, that's simple. That's 6. So we're going to take the distance it is, that the number is from the lower, and put that at the top, and we're going to divide it by the total distance. So it would be 6 over 17, and then we're just going to divide that. So 6 divided by 17. 6, I'm going to put a couple of zeros in here. Put a 17. So we move my decimal straight up. 17 goes into 60 3 times. 3 times 17 is 51. Subtract, bring 9, bring down the 0. 17 goes into 90. Let's see. 51 and 17 is 68. Yeah. So it's going to go in 5 times. So that gives us 85. 5. 0. 17 goes into 50 twice. Minus 34. And we can keep going. Add more zeros, but that's close enough. So it's going to be, remember, 8 is our lower number, so it would be 8.352 would be the answer that we'd put. Okay. So let's try one more. Last practice problem for this. So what is the square root of 18? First, the square root of 18 falls in between the square root of 16, which is 4, and the square root of 25, which is 5. So I know it must be 4 point something. So let's talk about the distance between 16 and 25 is 9. The distance between 16 to 18 is 2. So this is going to be 2 over 9. So if we divide that, 2.0009. Okay, so 9 goes into 2 0 times. Move my decimal up. 9 goes into 20 twice. Minus 18 gives me a 2. Bring down the 0. I've got another 20. So there's 2 repeating. So this would be about 4.2 repeating. Okay, so go ahead and try these on your own, and I will see you in class.